during the past days I wanted to elaborate more on this circuit. Minimum component square wave oscillator, and this is the schematic, and I will surely give the link in the text box. I told in that video that when you make these two capacitors here and here very small, you could get even higher than approximately 800 kilocycles, but that was only an idea for experiments, and well, that's completely true. I tested it now here with two capacitors of 33 picofarad, and I found very strange phenomenon. I can say, for instance, when you change the voltage here, the frequency will change. That's of course completely logical when we look at the theory of A-stable multivibrators, etc, etc. Good advice is here to use a LED parallel to the circuit, so that you can do, when you use the start switch, you can surely see that the circuit gets its voltage. And we are now here. I see this beautiful waveform, and the frequency meter tells me that it is 20 megahertz. Well, that's completely unreliable. When you do these experiments, of course it could be that we are now on 20 megahertz. But when I change that potentiometer here, the waveform changes, everything changes, the whole circuit gets into a wild oscillation here. So here there is that 20 so-called 15 megahertz or 20 megahertz sine wave oscillation, and here it's more fierce, and here we have also that. But anyway, it's useful. By the way, I have to tell that I mounted here a 10 nanofarad capacitor here, and now I have these results. Say that 20 megahertz or so, or not 20 megahertz, completely unreliable. So here is that gap of 10 nanofarad. Anyway, in a certain way, I have to say, don't believe me. Do your own experiments, etc, etc. Of course, all these, say, all the components, also the output gap and the series gap and the parallel gap, play a role here anyway. So let's look again. Surely not 23 megahertz, I think. Do your own experiments, take your counter, etc, etc. Well, let's go to the more wild oscillations. When I tune here that potentiometer, so here we are on, so here we have a wild oscillation, completely wild, and by the way exactly the same circuit, and now the counter tells me that it is 3 megahertz. Well, could be, of course. There is a certain period here in between, etc, etc, but say the video is not about that. Anyway, let me show more wild oscillations. So here's again a wild oscillation, and I change now the voltage here to the oscillator. Let's see what happens. there's a certain voltage where this wild oscillation is there. I now go to a lower voltage, and here, say on 3 volts or so, perhaps there's a good waveform. I absolutely don't know that, but anyway, yes, there's a good waveform. Counter tells me it's 14 megahertz. I don't believe that. Lower voltage. So, and this is say the lowest voltage that where this circuit can work. It's 14 megahertz. Well, believe me or don't believe me. Anyway, well, the circuit again. I want to keep this video as small and short as possible. This, by the way, works very, very properly. No problems with that. The bonus circuit is here. When you want to make a LED lantern and you don't have, say, I switch off the lights now. You don't have, say, a certain solar panel. This is a very good circuit. It's made with the, say, the chip that does all the Chinese solar lanterns all over the world. And the reason is, that's the reason, by the way, why it is only 20 cents or so, or 50 cents. But you can buy it via Ali. But apart from that somewhat criticism, it's a beautiful, beautiful chip. Here it is again. I also made another video in the past. And the LED now lights up. The whole idea is that also with very, very depleted 1.5 volt batteries, you can make a small lantern that will work even with depleted batteries. I tested this during the past days. A depleted battery also works for 3 days, giving that LED enough energy. So the whole idea of that LED is, in my opinion, very good, kind of blessing, in that way that we can use also very, very depleted batteries for a proper use. Anyway, thanks for watching. I will try to make more out of this circuit, trying to get to smaller capacitor values, especially lower than 100 picofarads, and then say try to get more stability in this oscillator circuit. But anyway, this is fun. So switch out the lights. Let's look. Oh, out the lights. Let's look at this beautiful LED that lights up with the help of this kind of Yule sieve circuit. And this is a small inductance here, 470 microhenry, works good